Hi, welcome. How was your early September? Yeah? Who's keen for the end of the year? No one? Someone? Put your hand up if you're looking forward to Christmas. Okay, so the best thing about T3 is that it's the end of the year. That usually makes everyone happy. It's good. It'll be over pretty quick. But the downside of T3 is you're all pretty tired by now. I can see it in your eyes, your half-open eyes. You've been through 2 terms of hell. You're feeling a little bit drowsy. But you're here nonetheless. And the cool thing about teaching this course is it's an elective, which means if you're here, you actually logged onto a website and specifically chose this course over other courses, which means I can pretend that at least you are half interested in things. As you can see up on the screen here, I have my slides, and here is the Slido where you can ask questions. Ask questions all you would like throughout it. I'm going to dim the lights now. I just turned it up to 100% to have a dramatic effect when we bring them back down. So we'll stay like this for the rest of the night. Now, quick intro from me. So my name's Hayden. I run the course. I started this course back in 2020, and I've been running it every term since it began. I work full-time as a web developer, or more specifically running a team of web developers. That's really what I get up to day to day. I love web design. I really hate talking about myself, but someone told me that they'd appreciate just a minute of context in the feedback. It's the thing I've been doing the longest, probably like 10, 15 years now. Ever since I was like in high school, I made my first dollar selling someone a website for $100. It was really shit, but they still paid for it anyway. And then someone told me they'd give me $2,000 to build them a website, so I built them the website. And then this mysterious friend I met on an online chat room from England didn't talk to me and didn't give me the money. So I've had a very touchy background. But I just wanted to give you all context. I fell in love with programming through the web. And one of the reasons that I'm sure so many of you are interested in this course is probably similar to me. It's nice to build stuff and for people to use it, right? Like so much of what we do at uni and whatnot, it's like we're going to make a service. And anyone dealt with MIPS and microprocessors? Right? Like it's cool, and I don't want to downplay that, but there's something very different about just putting something in someone's hand. You know, I think the very earliest memory I had was being in I'd made this thing for someone. It was a little web app, and it was to do with credit cards and how they entered details. And it was some 35-year-old guy from Melbourne that I knew. And he spent 20 minutes a night fiddling around with all these numbers. And I made him a tiny little website where he could put these numbers in and it would automate it for him. And he messaged me and he's like, thank you so much. I get to, like the last week I've been able to put my kids to bed because you made a little app that helped me just save 20 minutes of my day. And I was like, wow, isn't software powerful? And isn't it great that you can, touch people's lives directly? All software generally helps people, right? Like if you're working at YouTube on some system that does intelligent buffering of YouTube videos, that's really cool, and that touches a lot of people. And that's as important, if not more important, than stuff we do with front ends. But the coolest thing about front ends is that we get to see people use it. You get to build stuff and people get to touch it. And that's really what this course is about a bunch. I'll get to post these questions, and I will kind of slowly go through them every 10 minutes or so. So I just want to get straight into some stuff. So why COMP6080? I've gone and updated a bunch of these stats. ChatGPT was very useful for this time around, but I did cite them. I thought it was really interesting because I kind of know this. I'm like, well, JavaScript, right? And you all know the course is in JavaScript. You've signed up for it. Put your hand up if you don't know that we're doing JavaScript in the course. Cool. OK, so you kind of all get that. It's just massive, right? Is it the best language in the world? Is it the coolest language? Is it the most impressive? Is it the nerdiest? Probably not. There's a lot of problems with the web stuff, but you can't deny its relevance, right? So some stats up here. 65% of professional developers reported using JavaScript from Stack Overflow's developer survey. JavaScript's the most active language on GitHub. All of these are going to have biases, obviously, right? Because there's going to be a lot of projects and languages, like C-type languages, that maybe aren't on GitHub publicly as often as other types of things. So there's biases here. Other ones, the vast majority of websites use JavaScript as their client-side programming language. Frankly, I don't really know what the other 3% use because everything's kind of JavaScript. And React.js, which many of you know about, I'll put this back on the slides in a sec. This is just up at the start, so if you want to ask a question, you write the number down. So if you're going to ask a question, write the number down and go to the website after. But React is built on JavaScript, and React is used by a significant number of people too. So the short story of all of this stuff is that like web is the most of everything these days, right? For better or worse, whether it's good or bad, whether we like it or don't like it, it's significantly relevant. We can't escape that fact. So we need to pay attention to it. Now, the purpose of the course in the next 10 weeks is I want to make you feel really confident in building a web app. That's the plan. So I want you to feel like at the end of this course, which is really, really soon, it's actually just in like, what, November? Like we're in September, right? September, October, November. So super soon, you're going to sit down and be like, if I want to build a website, I can just go make it myself, right? I know what to Google. I know what to research. I know what to type. I know what to do. It will all be within your hands. You might not be an expert at everything. You might not feel super confident, but you'll be able to do it, and you'll be able to take what's in your head and bring it to life with a variable of how much time you have to spend on it. It depends on the individual and what you're trying to do, but you'll be able to do that. And that's really, really cool. So 2 important questions before we get much deeper. What is a front-end developer? And why is web exploding? Because I've spent this time here being like, well, yeah, web is exploding. I've given you lots of stats, but I want to talk to you about why, because I think that why is really important, and I bore all my students at the start of every term with that particular why. So firstly, what is a front-end developer? It is someone who writes code for typically a client-side device, right? And it's typically end-user facing as well. It doesn't have to be those two things. And what I mean by that is that there's lots of people out there who write code that is client-side, but maybe the user doesn't see it. So what I mean by that is, you might have an app or a website, like take slides.com here. There's a lot of logic that might be going on behind the scenes to organize and arrange this stuff. You might not be making boxes and pretty icons, but you will be inevitably still actually being part of it. Because remember, when you do stuff, like even these slides here, all these things we see on the screen here, all the things on this website, they're all running on my laptop. My laptop's the machine that's executing it. But these things are talking to servers somewhere. So for instance, with this website, the course website, it's getting a lot of this information from a server that's sitting somewhere up on a cloud in some AWS center in Sydney, right, that CSE runs. And same kind of thing for this one. They're probably both talking to AWS or Amazon in these instances. And that's running all this other code over here. Whereas what you're seeing here, this actual page, all the colors, that's running on my browser, on my computer. And that's what makes people a front-end developer, essentially, right? It's not some, like even though the languages are different, we're all engineers, we're all software developers, we're all computer scientists. It's all coding one way or the other. A lot of it's just where it ends up getting executed. And what I mean by that is that, if you're not sure what I mean, a lot of front-end stuff, if you code it, you can run it even if you don't have the internet connected a lot of the time, right? Whereas the back-end stuff you can't, because you write something on a server somewhere in Western Sydney in some data center, and then you lose the internet, you can't talk to that server anymore. So that's kind of the main distinction. I think this last line is really important, is like building things for people to use. It's something I notice a trend with, is like a lot of people who take this course really love product. And product's really interesting. I don't want to go off tangent too early on in the lecture, but in our industry, a lot of companies, a lot of the big companies, you'll see a very similar pattern. They'll have a team of people. There'll be a bunch of engineers who code stuff. There'll be like a designer or a couple of designers who go and make pretty things, artistic types. And then there'll probably be some product people in between that are doing things like managing the team, managing the engineers. Maybe they're trying to figure out what to build next. Maybe they're trying to figure out, what's wrong with this course site. This course website's a little bit of a piece of shit. It kind of is a little ugly and not the best. And it doesn't do great things. And someone might come along and be like, oh my God, the course website's so bright. Why don't we introduce a dark mode or something like that? Like thinking about the user. Maybe they don't have to be a programmer, but they're focused on how to improve the product. That's also really relevant. And just one thing to point out at the start of the course, you don't have to do this stuff and love this stuff and then be an engineer. Some of the best product managers I've ever met, come in. Unless you're not studying the course, then come in anyway, I guess. Some of the best product managers I've ever met in industry are really capable engineers, because it is so much easier for an engineer to understand product than it is for a product person who doesn't have an engineering background to make sense of code. So that's just one general comment, is don't feel like you have to be a coder. You can do this stuff, learn this stuff, and just be focused on users and products in a whole bunch of companies out there. And there's a real shortage of product-focused engineering people. I have a bunch of friends at Tesla or ex-Tesla, because I did a bunch of solar car stuff at uni, and they used to hire everyone out of solar cars. So I talked to a lot of people who worked at Tesla, and they were telling me that for a long time, maybe even now, I don't know, Tesla would only hire people in that whole space with engineering backgrounds. Even if they weren't coding or doing, mechanical stuff on a car, they'd be like, we need people with a strong technical understanding to work with the people with technical understanding. So that's also really important for you in this course. Now, before we get into a quick bit of history, there are no questions that are worth answering yet. Because we will probably come across them, or they're just not so urgent. So this question, why is web exploding? Why is web more popular than it was 20 years ago? Does anyone want to give me an answer, or a part of an answer, or just anything? Give my lungs a break. Yeah?
We have a lot better hardware to run things.
We have a lot better hardware. Yeah, that's true. That's interesting. That's true on a very particular part, which is like, you go back a long time ago, what you could do on a website was quite limited just because computers weren't very good. Even now, some websites that work fine on your laptop will be really slow on your phone just because your phone's a little less powerful. So yeah, hardware is definitely a relevant part. Any other reasons? Yep.
Potentially different operating systems, because web applications you expect to work across different operating systems, but if you want an application, you have to adapt for different things.
So step me through that. So you're saying that it's because operating systems have changed, or?
I think there's like lots of different ones. So that a web application you can.
Yeah, absolutely, perfect. So web applications, like if there are many different operating systems out there, how many operating systems would you say there are, if you just had to guess? First number that comes to your head, go. 3? Who said 3? You said 3? What 3 did you think of? Mac, Windows, and Linux. See, I like that. And you can expand on that, which adds and proves your point, which is you've also got your Android and your iOS, right? Because everyone has these phones now. So it's like, exactly, for laptops, desktops, you've got those big 3, and then you've got Android and iOS. I don't know if anyone still has a Windows phone, if they died out. I'm sure they're all dead now. But there's, I don't know exactly, but you could call it like 5 operating systems, or if you just took the general public, call it 4, right? You got Apple's laptop and phone, and you've got Android on the phone and Microsoft on the desktop. So that's a lot of different things, whereas you can make one website and you only have to do it in one place. So why wouldn't you just build a website as opposed to making 4 different applications? Was there another kind of answer at the front somewhere? Yeah?
Well, I was going to say that there's a lot of our information is on a website instead of just newspapers or a book. So there's a greater need for stuff to be on a website.
Yeah, consumer habits are a massive thing. So we're seeing more and more people just use their bloody phones and computers, right? So therefore we need to put more and more stuff out there. Like 20 years ago, I'm sure, like even now, my dad probably still reads a newspaper. So like there was less needing to do stuff on the web, Whereas like now there's quite a lot. So that's definitely true. I want to take you through a little bit of the cool thing about the web is it's got a really short history. One thing, one of the people I used to lecture with, they said something that always used to blow my mind, which was like, Hayden, we've only really had computers for 50 years. We still don't really know what we're doing with them. And we're going to look back in 1,000 years at like right now and be like, wow, we really didn't know what we were doing on like anything. And this is true for this, right? Like web is really young. It's 2024. Most of this started in like 1993. So it's only 30 years old in terms of like before that, there just wasn't even websites. And even the websites we know today are pretty unrecognizable from things in the past. But I think there's a few really key moments that change things that are really important, I think, to understand where things have gone from and to. The first one is like HTML is a really simple language. We're going to do a little bit later, but it kind of looks like this. You have an HTML page. I say, here's some bold text, and then I can go and put in like a paragraph of text. Many of you have seen this before. Even if you don't understand HTML, I don't know how, but everyone's kind of seen it around somewhere, Whether it's by accident, you might not know what the hell you're looking at, but it's got a recognizable look. This stuff simply allowed you to make pages that look like that. I know that's a really poorly scaled image there, but it's basically just a black and white web page. And that's, again, Internet v1. It was pretty much just like text and pictures. The examples I always give with students in this course, I always love pointing to Wikipedia because so much of Wikipedia could have been built in 1993. It's a really simple website. It's just kind of like buttons, a couple of colors, some headers, some text alignment. This website would have looked normal 20 years ago as well. It really hasn't adopted much of the modern web tech, so it's a really good kind of look into the past of how the internet used to be, which was essentially a store of information. HTML as a language, it was brought out so that people could exchange URLs with each other to kind of access documents. It was like a big giant Dropbox of like files. But instead of PDFs or text files, it was HTML files. I do every term, I do a random article together. This one looks slightly more interesting. 4-string pear-shaped fretted lute used as one of the many primary traditional musical instruments of China. Dance of the Yi people. All right, let's YouTube this one real quick. It's kind of interesting. Normally I get really boring ones. You're in luck today. Double ad. Does anyone else get the second ad and just wonder if you're going to quit YouTube permanently? That's kind of cool. I don't want to play it, but I'll go play it later after on my way home. Anyway, that looks really interesting. But it's like Wikipedia, a pretty simple website. There's nothing really there. It could have existed in 1993. People eventually came along and said, you know what, that's kind of ugly. I don't really like that. So a few years later, they introduced the two really important languages that form kind of the trio of the three languages we build websites with, which is CSS and JavaScript. CSS was a language. It looks pretty. It's a weird, funny-looking thing. It kind of looks like this. It's just that repeated. We'll go through that obviously in the course. It was all about aesthetic. Everything to do with CSS, the language, was about adding color, shape, like eye candy to stuff. It wasn't really about adding cool functionality or anything that actually made anyone's lives more useful. It just made them think of it like more pleasant, right? So it's all the color stuff. So when you look at this page, the blues, the layouts, how big a button is, it gave you so much more control because the original kind of HTML standard didn't have a lot. It was kind of like, hey, you can have a button, you can have some text, you can have a link. Do you want your link to be purple? Do you want it to be rainbow? Do you want your background to be a gradient? Too bad, that doesn't exist, right? So CSS came along and tried to make stuff pretty cool and interesting. If I go back to the home page here, I'll give you an example, right? Like this background color here is like green. Sure, I'm just basically playing around with the web page here, and I'm going to go and try and change a few things. I think this is what I want. I don't know. Yeah. So this is what sets the background color. This is CSS. You could have done this with the old HTML, but CSS would be like, well, here's some extra stuff. You can go and I don't know how to make these off the top of my head. I should probably Google it. I'm not teaching you anything here, just for the record. I'm kind of just trying to get you interested. Yep. Oh, no, it's sad. Why is it sad? Invalid property value. Go away. That's strange, actually. Wonder why that one's not working. Don't know. Point is, I can just show you on this website. Don't really need to not really, there we go. You can make really gradient colors like that, right? So this one's like green through to orange. I'm not sure why that wasn't working on the page, but the point is CSS started to open up a whole can of worms that over the next 20 years would allow you to make things really, really specific. And most websites that you see now, I'm trying to think of like, what's a good example? It's always good to pick on UNSW. It's like there's not really a ton to this website, but things like even adding this big yellow blob to the page, or adding these shadows to these boxes, right? You probably don't really think about it, but there's a shadow on that box. Or even, being able to put a background image behind that text. This is a very simple page overall, but there's still definitely a few elements that wouldn't have been possible without CSS. Now, the other thing that came along at the same time was JavaScript, and JavaScript was the complete opposite to CSS. It wasn't really that interested in we exist to make everything really pretty and colorful. It existed to add functionality to stuff. JavaScript is what made web pages more than just static documents, right? It really distinguished them from a really nicely made PDF. It gave them life. JavaScript is what allows this website, because we're on a website here, right, these slides, it's what allows me to click left and right and for it to do all these kind of dynamic things. It basically allowed us to respond to user input or certain behaviors. And if you think about it, most websites at their core are simply a response to a user click on the mouse, a user keyboard press, or some moment in time passing. Like a whole website is just some series of those actions occurring and then it responding in some way, typically visually, right? Like Netflix, two inputs, you hit a button, you go to the next page. So JavaScript provided the bones of allowing us to do that. It meant that we can do something like this collapsing and expanding, right? That was JavaScript adding some dynamic elements to the page. they're not all totally separate, right? They all work together. You can't make a website in just JavaScript and no HTML and CSS. You can't make a website in just CSS and no HTML and JavaScript. So the introduction of that really completed that. These are the three languages we use to build the websites. And for many of you, I'm imagining a lot of you born, put your hand up if you were born between 2001, 2005? Yeah, okay. Probably got that slightly off. But, sorry, I just lost my camera. Okay. Yeah, it's like a lot of you, your earliest memories of the internet would have been maybe a very pretty, colorful internet that couldn't do too many wild things, right? Like you weren't watching Netflix when you were 6 years old. I don't know how old Netflix is now. Maybe it's really old. But there's a few cool things we can do now. So that kind of carried the internet into the 2000s. The next thing that really jacked it up and turned it from just a pretty set of pages to something more interesting was the introduction of this thing called AJAX. We learn a little bit about this in the course. It stands for Asynchronous JavaScript and XML. The name doesn't really matter, but basically it was a technology that enabled web browsers to make requests to web servers quietly behind the scenes. Now this might not mean a lot, but the way the internet used to work was that you would type in a URL, you would hit enter, it would make a single request out to a server, that server would return information, and that would be your web page forever. And the web page would stay like that. And if you wanted more information or different stuff, you would have to make another request and get another web page. And again, a lot of us kind of understand this because it's how things like Wikipedia work. You'll notice that every time I click on a link, it actually it has to go away and load something for a second. The little thing up the top spins, and then it's like it rebuilds the entire page, right? Philippines. When I click on this, right, it's getting all that information every time I do a click, and it's having to create a whole new page. The introduction of AJAX meant that what pages could do is they could quietly make those requests for you without refreshing the page. Now that might not seem like a big deal, but that was pretty important because, and I know a lot of you probably are a little too young for this now, I would guess. I know there's a bunch of you who are way older than me in here too, but it's back in the day, if you had an email inbox or an Instagram inbox, you would have to refresh the page to see if you had new messages, right? Because it would load in, right? And I'm seeing a few head nods. And then at some point, they just figured out how to make you not have to do that, right? You just open up Gmail and you sit there, you click forget password on a website over here and it just pops up, right? You didn't refresh Gmail, you didn't click a button. Gmail was quietly sending a request to a server behind the scenes and getting more information and doing that quite often. And this is happening all the time now on all of our websites. And it was super transformational because what it meant was that websites could start doing things that apps could. That's when we started to see the death of Outlook. It's still with us today. But these Outlook apps, right? I remember as a kid, my mom used to have Outlook for work on her computer, and it was a whole app and stuff. And Gmail and stuff wasn't as popular because it just couldn't do as much because it just wasn't as powerful. You weren't getting emails in your inbox in real time. So that's probably one of the more transformational things that kind of happened. And in a lot of ways, a lot of the web is really just an extension of where we got to in the early 2000s with it, which was we could make pretty things and they could do a lot of stuff. They couldn't maybe be a full video game yet, right? Does anyone here play video games? Is it Steam? Steam where you download games? Cool. That's not a website, right? There's a lot of stuff the web browsers still can't do because they're just not as powerful as building to the hardware directly. But it can do quite a lot. Now, the next couple of things in terms of the history that took us from 2010 through to now, so the last 15 years, aren't so much a fundamental change in the web technology because it's been pretty similar. They're a change in, I guess, what I call the industrial inputs in things, which is really, really important. I'm going to get the notes back up for a second too, whilst we're chatting. In particular, Microsoft, LinkedIn, a bunch of those other companies, they started putting a lot of their time and resourcing these open source projects, which left us with a couple of really important ones. One was Node.js, which a lot of the undergrads are familiar with, which was basically they took the JavaScript language, which was designed and built to be run in a web browser, and they said, what if we just make a command line interface like we have with Python? And they made that. So now you could run JavaScript on your terminal. You could write a .js file and just run JavaScript code. They called that Node.js. That was pretty transformational because for the first time ever, ever you were able to build a website in one language top to bottom. So you could go build an entire website, front end and back end, all in JavaScript. And that was still pretty cool, but not enough. JavaScript wasn't as robust as languages like Java, which is unrelated to JavaScript. They have nothing in common. But Java had typing, right? Like strings, ints, array lists, all that kind of stuff. And what that gave Java was it gave industry comfort. Because when you have like a 1,000,000-line code base, you know what you'd really like in your language? Types. So that you know if something's going to go wrong before your code runs. And if you don't have that, it's kind of like every time you hit that run button, something bad could really happen. That's why you don't really see a lot of like Meta or Google being like, yeah, we run Google search in like Python, because they don't scale as well. Now Python does have types. I don't want to, otherwise I get an email like at 10 p.m. Someone's like, Python does have types, Hayden. But the introduction of TypeScript changed that a lot too, because with like backend JavaScript and typed JavaScript across that, you started having big companies be like, yeah, we could do that. And think about this, really interesting. Canva, when did Canva start? 2012, right? Out of Western Australia before they came over to Sydney. What do they build their entire infrastructure in, ignoring any services? JavaScript. What has Atlassian been moving a significant amount of their new services to, away from like Java stuff, is like JavaScript. So these things were like insanely critical in getting these like billion-dollar companies to be like, yeah, we could probably build something on that and it won't break and it'll be good for our teams. So that was really important. And then two more things. I'd say this one was a little more about tech. Has anyone heard of like Electron apps or hybrid apps? A couple of people. So this one's really smart. I always thought this was like the dumbest, easiest thing. And there's probably some newer ones. These slides are a couple years old. What they did was they said, hey, you know what? Websites are getting really convincing. You go to Netflix, right? Netflix.com. Who uses Netflix? Is anyone more of a Disney Plus person? Couple people? OK. Whatever streaming service you use, does anyone subscribe to like 5 of them? Does anyone actually do that? I kind of phrased that question badly. Phrase a question like that, no one puts their hand up. So you go onto these services. What they did was, instead of you having to go to netflix.com, they made an app. They put it on the App Store or the Windows Store called Netflix. And when you download that, what it actually is basically a Google Chrome web browser, except they get rid of all of this stuff, right? See from like the top here, the tabs and the URL bar and everything else. And you're just left with this part in the middle here, the main website. And when you open up that app, you know what it actually is? It's just netflix.com. It's just the app it's the app pretending to be, it's the app being a web browser, pretending to be an app on your computer, just like a normal app. You've probably already seen these. Microsoft Teams, as far as I know, does that. VS Code, as far as I know, does that. Discord, as far as I know, does that. Slack, as far as I know, does that. It's actually really, really common. And back to your great point at the start, why was that really popular? Because everyone said, oh my God, you know what we can do now? We have to build for Windows and Mac and Android and iOS. And you know what? Let's just make an app for all of them. And we'll just make it all a web browser. And then it can all just load up netflix.com inside of it. And then we can ship it and everyone can get an app on their screen and in their computer. And then it's really great. Why would we do anything else? We can just build one website. Now, there are problems with that. Websites are never going to be as fast as native applications. I won't drag you through a long-winded explanation, but for instance, with my company, when we launched an app, we had like 2 people at the time. We literally launched an app, and we just made it a website in disguise. So whenever you downloaded our app, you're actually just browsing the website. It just felt kind of like an app, but a little shit. Over time, we then eventually built an app specifically for the phone and kind of had a website slightly differently as we kind of got a little bit bigger and had more people. But that early stage was like so important because you could just build it in one place. You'll see a lot of websites that'll talk about build once, ship everywhere, lots of stuff like that. And then the last piece, which is also really important, is actually, I'll go to your question first. Yeah.
What about things like WebAssembly
WebAssembly, that's so interesting. I confess I don't know a great amount, but what I do understand is you got to think about, and we'll talk about this later too, your web browser, like Google Chrome, is a compiler. You have to think about it like a compiler. You write code in it, it loads up the code, and it compiles it into something really pretty. Web browsers right now only understand JavaScript as a general rule. That's the only kind of programming language they know how to interpret. They don't know how to read Python. They don't know how to read C or anything like that. WebAssembly is an interesting language that they kind of, I don't know how old it is. It's a few years old now, but it's basically, if anyone had a good time with MIPS, you'll, they basically, these sadistical people, they were like, I don't know anything about WebAssembly, but they were like, well, we'll write another kind of language that's like assembly, and we will kind of set it as a standard, and then people like Chrome and Firefox and Safari who make web browsers, they will start slowly adding to their compiler to understand this as well as JavaScript, you know? And the reason this is interesting, because you might look at this and be like, well, why? Why would I put myself through that? One of the reasons this is interesting is because, think of it like this. One day, if you can find a way to get another language to compile into WebAssembly, that means you can start making websites in another language, right? Because you think about it, it's like C++, C, they all kind of compile things down to machine code, right? For the machine to run kind of base instructions. So if you can get like a language like Java or Python to compile things down to WebAssembly, then it can execute WebAssembly on the browser, and then suddenly you can build a front end in Python. So we're a long way off that, but that's about as much as I know on the topic. But it's very interesting. I guess the long-term hope is that in 10 years, we don't all sit around having to learn JavaScript if we want to make something, hopefully. Do you know any more about it than I do?
Not too much more, but like I've seen projects that are trying to use it to build like more high-functioning performant apps.
To build more what?
Like to build more like high-functioning apps that are more like focused to the
Oh yeah, exactly. Like that's a great point. I glossed over.
I think Adobe's doing a project where they're trying to redo Photoshop and like those big apps, but in WebAssembly.
Yeah, definitely. So like C++ is faster than Java, right? And that's because it's not virtualized. Like Java's got this abstraction layer in between it that makes it easy to deploy on multiple machines. So direct to hardware is always faster. We kind of know that. The web is like layers, you know? The abstractions slow it down. So even if you do something really, like a basic function in JavaScript through a web browser will be way slower than direct to hardware stuff. The other part about WebAssembly that was being mentioned there was that the cool thing about this is because it's a lot more base operations, you're kind of removing some of those abstractions. And that'll mean that in the future, hopefully, we can have things like maybe video games, or Photoshop's a really good example. At work, we use a tool called Figma. I'll probably show you in the next few weeks if you haven't seen it. And it's like a graphical tool. And my computer like craps the bed trying to use it because it's just so like high powered for the web browser. You know, the web browser is kind of like it's like a shackle on the speed of it. So there's a lot of cool stuff like that we might see with WebAssembly. So hopefully we'll see more of that. In the meantime, the biggest things that have had an impact are what we call declarative frameworks. That's a technical sounding term. It's things like React and Angular and Vue. So React was built by Facebook. Yeah, Facebook. Angular was sorted out by Google, and then Vue, I think, was a mix of people. I don't think it was like one specific big company. Google kind of led the way with this a while ago, but React kind of took over. Is React the best one? I don't know. I don't much care. You know why I don't much care? Because it seems to be half of what everyone does these days, and that's kind of why I use it at work, because everyone else is using it. You know what that means? That means everyone else is going to use it. And then we're teaching in this course because everyone else is going to use it. Canva uses it. Atlassian uses it. So then you all use it, and then, you know, I mean, it's like, it's a bit of a circular thing, right? So this isn't some merits of like React is the coolest framework, it has the best merits. It's just the most predominant one by far. It's going to be very difficult for me to explain to you why these were fairly transformational to the adoption of web front ends being more and more prevalent and programmers enjoying them more. Difficult until we go and do it, like in week 7 and stuff. So for now, it's more like this made working with stuff far more efficient and quick, and you're going to get exposure to that later on in the course as well. Okay, couple of questions. So someone says, hi chat, hello. Hello. This course is giving me Ligma. That's an in-joke for a few people, I think. Can I use HTML for solving DSA LeetCode? Okay, so DSA, I'm assuming, is data structures and algorithms. You definitely cannot. Again, I'm not an expert on this, but as I understand it, if you look at the name HTML, it stands for Hypertext Markup Language. It's not a programming language. It's a markup language. And what that means is, again, I don't know the formal definition, but for something to be a programming language, you generally need to be able to do a couple things like if, else statements and loops and stuff. HTML is a lot more like Markdown. If everyone knows markdown.md files, it's like that, but a lot more advanced, but still in the same spirit of like you just write something, declare, and then it just kind of exists. But it's definitely a lot more, thorough than that. Will the course as fearful as 6771 and is the final exam double pass? We talk about assessments later. I taught C++ this year. I think when it comes to C, they're different things, and I mentioned this in the slides, so I'll kind of cover that. So assume knowledge, we assume you know Git, we have a basic understanding of HTTP and web browsers. The undergrads will have a slightly higher degree of prerequisite knowledge they already have than postgrads, but we help the postgrads out with that, which we'll come to in a sec. This is the content we cover in the course: HTML, CSS, lots of JavaScript, because this is all JavaScript down here. We talk about old school JavaScript from the 90s. We also talk about JavaScript in the world of like networking and stuff. There's a lot of JavaScript. So it's mostly a JavaScript course from kind of week 3 onwards. These are a few things we don't cover. You don't really need to worry about them. There's just going to be the occasional person in the course that really wants to learn about some of these things and knows exactly what they want, and we're just kind of telling you that we don't cover that. Learning outcomes are on the course website. Okay, so this one's really important, and it kind of touches on the C++ thing. So this course is very different for a lot of you. Front end is very different to a lot of what you learn in your degree, and that's because it's a breadth topic. Breadth topics are particularly tricky for some people. Some people love them. What I mean by that is that data structures and algorithms, right? Most people have done, I think it's like, what's the postgrad data structures and algorithms? Is it like 9024 or something? Yeah, okay. So like you've either done 9024 or 2521. Now, if any of you ever sat down and been told to write a quick sort or a merge sort, you would know what it's like to have a very simple to describe problem that you just have to solve really specifically. And you could write a lot of code, and there could be edge cases that you get wrong, Front end is very, very different to that. It's the polar opposite. Nothing you do in this course is going to be particularly difficult. You're not going to feel like you're solving rocket science equations or anything like that. You're going to feel like you're battling a very large stack of different technologies and many different ways of doing stuff and gluing things together, right? It's like death by 1,000 cuts. And one of the worst parts, or the best parts, is that you will be able to see if your stuff works straight away. You type code, it comes up on the screen. Is it blue? No, it's not blue. You screwed up. You got to make it blue, right? Now, the reason I point this out too is, and I've learned this from teaching it so many times, this kind of course can mess with your head, because in another course, take C++, which I ran last term, you can give students a problem, like write a quick sort. Every one of those students can submit it thinking it's working. And not all of them will get 100%, because they miss some edge cases. They miss some stuff, right? Because it's a very complicated problem to solve. But with front end, you kind of know when you submit your assignment if it's working or not. You know at the point of submission kind of what mark you're going to get, because it's obvious. A tutor's not going to unpack something on your website. Like, they're just going to look through it and see if it matches the assignment specs and things like that. And the reason you just got to be mindful of that is it generally encourages students to work themselves into the ground sometimes, because if you're not perfect. And we'd see this if we say another course, we gave you all the auto marks before you submitted. You submit code you think's good, and then the auto marks are like you got 50%. You would just keep grinding and grinding until you ran into the ground. So it's just something to be mindful of, because I find students are generally pretty good when I give this little spiel at the start of the course. But beforehand, we just used to have students be like, I'm spending here's a good example. Students be like, I'm spending 60 hours on the assignment. And I'd be like, okay, what's your WAM? It'd be like 73. I'd be like, well, what mark are you trying to get? They'd be like 100. Everyone's kind of trying to get 100 all the time, right? I get that. But you kind of can keep going when you can see that you're not there. So just be a little bit mindful of figure out what your aims are in terms of how hard you want to work, what you want to achieve, and just be very comfortable in saying, okay, I've done enough now. Because the very nature of these assignments with front end, to a large degree, is you will just not finish stuff, And that's not because the assignment's too hard. It's just because the students who do finish everything, they smash through the early stuff because they understand the content so well, because they've done all the tutes, all the exercise questions and stuff like that. And if you struggle to the end, it's probably because you just don't understand the content well enough. And that's not some elitist thing. I did not do that well at uni, right? I should share my transcript. I occasionally meet a student who just thinks I got HDs at uni, and it's like, no, 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 no. Absolutely not. I finished uni, I think my WAM was like 71. That's not a bad WAM, right? Like, I don't think I'm an idiot. But put your hand up if your WAM's higher than 71. I know it's more than 4 of you. It's all right. I'm not going to put you on the spot. You get the point. OK, so we have a course site. It's called Eccles. It's right here. I made this. The reason I made this was actually, it's not because making custom software is a terrible idea. Don't do it. If there's tools out there, go use them. But I had a better idea, which was, I was like, I'm going to build this website using only the stuff that we've really learned in the course. Because I want you, as students, to look at a course website like this and to think, hey, I could go and make that pretty easily by the end of the course. That's also why it kind of looks a little bit ugly. Like, this is not some excuse because I'm crap. It's like, I was like, well, if we gave students an assignment, what would like a pretty average student's assignment look like? It would look like they've tried to make it look kind of pretty, but they certainly didn't get the little bits at the end right? You go to a lecture page and you're like, oh, what's this thing? There's just a blab of text up the top, right? So this course website's meant to kind of, I don't want to say inspire you, because like, who the hell would be inspired by this? But I want you to kind of go like, oh, OK, so we can go do cool things like this, as cool as this is. And the entire website's also open sourced as well. You should be able to go and clone this if you'd like to and run it. It's relying on stuff that we learn in like weeks 8 and 9. So I'm not saying go do it today unless you really, really want to. It's more like towards the end of the course, if you actually just wanted to play with it, you can. We've had lots of people push various pieces of code to it over the years. I've had random students just like randomly be like, I don't like that color, and been like, can we change it to blue? So, you know, that's always fun. OK, we've got a great team of tutors, big team, 40 of them. You're going to meet them. OK, really quickly on assessment structures. So, yeah, it's a level 6 course. It's really easy. You have 4 assignments. Now, I want to point this out. We used to have 3 assignments, OK? And we had 4. And I got some my experience feedback about this, which was so funny. A student was like, go back to 3 assignments. I took assignment 1, and I split it into 2, all right? Just to be really clear. So instead of assignment 1 being a 20% assignment during week 3 or 4, it's now a 15% assignment, and then we follow it up with a 5% assignment after. The second assignment is really easy. It's kind of unrelated to assignment 1, so we just thought we'd split it up so you can like segment those pieces of work. So there are 4 assignments, but really there's 3. There's an HTML CSS assignment that's going to, you know, be on your mind for a couple weeks. And then there's a normal JavaScript assignment, and then there's a React.js assignment. It's really simple. And then there's a small exam at the end of the course. I kind of covered that stuff already. It's probably a bit of repetition. Yeah, this is a hard course for some. I'll probably just touch on this. Some of you will find this course one of the easier courses you do at uni. Some of you will find it one of the harder courses. It really depends on how your brain works with a lot of this stuff, because it is just different. So don't punish yourself if you just struggle a little bit with it. Oh, some testimonials. I thought I'd add in these to the course. Just some nice things. Thought I'd sell the course a little bit. I like how the course changes its teaching structure to better suit how breadth-heavy front end is. I don't know. I added this like 6 months ago. I don't really remember adding it in. But I didn't talk much about the course website, but we do actually do a lot with the course website to cater to your specific needs. For instance, here we have all of the lectures sorted by week. If you're a postgraduate, you can untick this box. When you untick that box, you will get a couple of extra lectures for you to fill in some gaps. So that's really helpful for you. If you tick that box, it disappears. Also, these are 3 really important things too. What type of student are you? I want to do the bare minimum. I want to work hard but not go over the top, or I want to learn everything. Now, if you fall into one of these buckets, like I want to learn everything, then we show you every possible bit of content that you can learn in the course. But if you are friendly top one here, I want to do the bare minimum, we cut down a lot of the lectures significantly to the bare bones minimum. So if you only want to learn a tiny bit, you can kind of not watch as much during the course and still be OK, you know? We also sort things by topic with each lecture that we watch. So say the first lecture here, this one, it shows you the lectures related to it, the ones to watch before it, the ones you can watch after it. It also shows you exercises you can do after you watch it. So the course is like, it's a little bit choose your own adventure-y. That's mostly based on the premise that you're all level 6 students and you kind of can figure out your own stuff. Assignments are really fun, give so much. This sounded like a better idea when I put it in the slides, but it's just kind of a bit of a weird thing now that it's here. Where are the negative ones? This one's cute. By covering the basics, I feel like I have a starting point and am equipped to deep dive in my own time to expand my knowledge, which was the sort of the goal of this course, I believe. That's good. That person came in and they got out what they should have got out, which is really good. There's definitely worth the blood, sweat, and tears to come out feeling like I've got an applicable skill. I think that one's common too. We get a lot of students who are like, I'm just glad I can do something after. Of course, if you have problems during the course, reach out to me. I'm pretty quick to solve problems if you have them. And we always do feedback at the end of term. But I mostly just wanted to point out at the start that it's not the easiest course. In terms of courses at CSE, and I've studied a bunch of them myself, and I have a lot of friends who've done them, I'd probably put this course maybe at like a 7 out of 10, where 10's like the most difficult course and 1's like the easiest and 5's like the midpoint for the average student. Some people find it like lower. 5 to 9, average of 7, if that helps. Okay, a couple of things that are different about this course. Firstly, we do 2 hours of live lectures a week, and then we do 2 hours of pre-recorded. So today we have these 2 hours of lectures, and then after that, all these ones here are pre-recorded. We do that because pre-records we can usually get really concise, high-quality content, do it once, do it right, rather than the kind of messiness of live stuff. But generally speaking, you watch the pre-records for the week after the live lecture. But there are 2 hours of live lectures a week. One really, really, really important thing to note, and it does not matter how many times I say it, someone will turn up here in week 4 on a Tuesday. That should say week 3 on a Tuesday. I hate how much Tuesdays and Thursdays start with T's, but I want you to please pay attention to the fact that for most of this term, we actually have our lectures on a Thursday. A lot of this has to do with the timing of content and when assessments are due, and a few things to do with week 7 that I won't bore you with. We'd probably do the whole term on Thursdays normally, but we did the first 2 weeks on Tuesday just to be like, hey, let's get started, because no one wants to wait till Thursday in week 1. You just kind of want to get stuck into it. Of course, these things may change. I'll always update you in the notice every week, so just read the notice. You don't have to think too hard about it. Tutorials are really interesting too. We have also grouped the tutorials in 3 different categories: compulsory, refining, and extended. Same principle here. I don't know why we use 3 different words for the same meaning, but we did. Compulsory means you should do it. If you don't do it, and you don't understand something, it's probably on you. That's kind of what that means. Refining's like, you don't have to do it, but if you do it, you'll probably feel like you mostly understand something to like pretty understand something. And then extended's kind of like, this probably doesn't have a great deal to do with the course, and you're probably not going to use it directly in the course, but it's useful knowledge, and some of you might appreciate that extra bit of work. The amount of time the lectures add up to every week is about 4 hours. Some weeks are shorter than the others, and it kind of depends on how much of the extra content that you do. We have help sessions this term. There's a timetable. I don't need to go through that. You kind of get what help sessions are. They're all online. A lot of our tutors are actually like graduates working jobs and things like that. They're not kind of 20 years old running around campus in societies and stuff. Most of them are employed, so we have to run stuff online. And then assignments we kind of already talked about. Okay. There's the forum. Go join the forum. Most of you are on it because I added you to the forum. I don't really need to say too much there. And then just in terms of getting set up, this one's pretty important. Getting set up in this course is really easy, particularly at the start. Later on in the course, from week 7 onwards, you need to kind of do a few things with Node.js and some other stuff. But what I love about this course, my favorite thing, you don't need to do any installation except Git, I guess, or play around with Git, because your browser is the compiler. All the stuff from weeks 1 through to 6, I guess 7, is all in the web browser. So getting set up is extremely trivial. I'm already set up and I haven't done anything, but definitely check out GitLab as well. We'll talk about GitLab a little more when we look at the first assignment. We do have a style guide on the website. There's a style guide here. Personally, I'm not that fussed about style, but we found that when we didn't have a style guide, students felt a little bit naked Like they were just like, oh, we asked you to do stuff, and you're like, but I don't know how it works, which is fair enough, right? Like you've never written this language before. You're like, should I do this or do that? Like I just want you to tell me so I can kind of take something away from it. So we do have a style guide there, of course, as well. And there's a feedback button on the side of the website too. Last thing here, related courses, I want to point these out too. It's also a question someone asked about here, which is, will we cover authentication, security, and web development? I love web authentication security. It's probably the first thing that interested me with web back in the heyday. But I don't teach it in this course because there's a course for it, and I think it's important to show that discipline. We could do stuff, but then there's going to be another course called Web Application Security and Testing. I don't really know much about the course, but I mean, I know a little bit. I know that it's about what it says. But if you're interested in the security side of web stuff, go for it. I'm happy to delve into some light stuff in our live lectures every week, which are a bit more of a demo. I think that's an important note too, is that the pre-records are meant to kind of teach you the content. And the live lectures every week are not really about, here's a new piece of content. It's often more like, let's build something. So think of it more like 2 hours of learning the fundamentals and then 2 hours of like demo every week. So most of our live lectures are going to be like just building, stuff. So there's a security course for web, and there's 2 courses to do with like product-y, UX-y kind of stuff. It's very abstract, particularly 3511. But if you're really interested in that kind of like what makes a good app, white space, layouts, how do users use computers, then you can go check those courses out as well. And yeah, I think that's actually kind of it there. Any questions about anything we've covered so far? There's a few here. If we did 1531 in Python, should we also watch the catch-up videos? Yes, anything to do with anything that isn't Git, I guess. Because yeah, all the catch-up videos are just COMP1531 lectures to do with Git and COMP1531 lectures to do with JavaScript. But I will say, and I will point this out, put your hand up if you don't know JavaScript. Should be a bunch of postgrads hand go up. Maybe many of you are not here, or you just don't want to talk to me. But if I untick this, and I get to where we learn about JavaScript here, they're big lectures. What I'd probably say, and I just will highlight this really quick, this one is basically learning JavaScript from scratch. If you know Python, which all of you, well, if you don't know JavaScript, you know Python. That's the situation you're in. If you know Python, I would probably just skip this one, and I would just jump straight to this one here, JavaScript language features and syntax, because it's a 55-minute lecture, which is pretty short. And we kind of teach it as if you know Python, if that makes sense. And learning JavaScript if you know Python is not hard, right? Like you kind of, you go through uni, you learn C, that's a whole other way of thinking. And then you kind of learn a scripting language, which is JavaScript or Python. And if anyone here knows JavaScript, you could learn Python very quickly. They're just kind of similar. The syntax is different, but the gist of them, the vibe of them is kind of the same. So don't feel like that's a big burden. Generally, the biggest comment I'd make to postgrads is just go and watch that basic Git lecture. What always happens every term is that a postgrad doesn't learn Git, and then they try and send me zips of your assignment. And like everything in this course has to go through Git, so we can't take zips of assignments. Why is there no lab session for this course? So it's pretty normal for a level 6 course not to have lab sessions. Generally, it's like the idea being that once you get to level 6 courses, you're kind of independent learners. And labs are labs are cool, but they're very like, come on kids, come into the room and like, I'll help you out with stuff. We have help sessions to compensate for that. We found when we did run labs, no one turned up, really. Like 90% of people didn't turn up because like, I'd want to go home. I'm an adult, I can teach myself stuff. So that's why we don't have it, but help sessions, think of help sessions as labs, like dynamic labs or something. I may have one of the most highest volume of help sessions for a level 6 course. We have a lot of help sessions in this course. Sure, not much in week 1, but after week 1, we mostly have help sessions every day. So as a student, on nearly any day of the week, you can pop into one of these and get help with something. So they are your labs, essentially. Someone also said, is there tutorials this week? Yes, you can check out the timetable. I know it doesn't say week 1, but they run every week except week 6, obviously. You can go to any tutorial you want, too, right? Like, obviously, the room can't be full, but put your hand up if you're going to skip all the tutorials this term, because I know a bunch of you will, because more than half of you don't turn up to all the tutorials in the term. So you can go to any one you want because they're not going to be full. I don't want to say that now. You might like test me on it, but if you're like, you know what, I'm on campus on Wednesday. I'm going to go check out Sophia's tute. You can just do that. You can join the online ones. Something I also glossed over, which is pretty important, is that, and we've invested a lot of time into this, with every tutorial question, we have already released the solutions. You can see them here. And we have a recording of the tutor going through the entire question for you. So you don't even have to attend the tutorials, because you can just go and watch the tutorials anytime you want. And they're broken up on a per question one. So this is Kai. Kai's an old tutor. I think Kai works at Canva now. This is a 7-minute video of Kai stepping you through this particular question and the particular answer and how he's doing it. So this is great because as independent learners, you're totally in control in this course. There's very little that you're kind of blocked on in terms of content and stuff in the course at all, which is great. So yeah, and then a few more questions. Differences between tutorials and help sessions. Think of help sessions like labs. Tutorials are just a tutor teaching you stuff. It's basically this video, except you're sitting in a room. And help sessions are like you turn up with a particular problem. Now, someone has asked here, is there a hurdle in the final exam? That's a great question. I don't think it's written on this page here. So I'm going to have to be very careful with my words here. But it does need to be written on this page. All right? Put your hand up firstly if you did COMP6080 last term, the C++ course. I just need to know how many people I'm dealing with. Great, like 4 of you. I'll ignore you then. So here's the plan. We started this course during COVID. One of the problems that courses like this have, it's true for any course, is people cheat, right? And it's pretty easy to cheat. We'll pull up ChatGPT after the break, and I'll show you some cheating stuff. It's lots of fun. And that's fine. Like I'm pretty bullish on LLMs and things we can do with them. But every time we have students who do this course, and they will either get ChatGPT to write it, which is very difficult to detect as a general rule, or they'll get someone else to do their exams, and they pass the course, and then we send them out into the big bad world where they don't know anything, right? So the way we get around that, generally speaking, is that you run exams in rooms where you lock people in the room, and you're like, yep, you're here. We know it's you. You can't escape. You have to know some stuff. These exams usually have hurdles on them because if you get 100% in all 3 assignments and then 0 in the exam, there's a very good chance that you cheated in the course, right? Because how would that happen otherwise if you're perfect and a genius, but then you can't get any marks in the exam? So that's kind of why hurdles exist. Now, I generally like that idea, and most courses are trying to move towards that. So this term is the first time we're going to attempt to have in-person exams on campus and have them as like in-person, in-the-room hurdle exams. However, this is a really important note. I've been very, very clear with everyone, tutors in the school, that an exam for COMP6080 that doesn't have internet access is stupid, right? Because as you'll learn very quickly, trying to do front-end stuff without being able to Google things is kind of dumb and cruel as a general rule. This isn't like C and C++. You can kind of understand those languages really quickly, but the experience of front-end is like there's a million different CSS properties, and I don't know exactly how to do the one I want. Like, how do I get a purple box with a rounded corner? I have to Google something to make that happen. That's part of the experience. So the plan is to do an open book exam. So basically, it's an exam in an exam room. Put your hand up if you've done an exam in CSE where you've gone into an exam room, right? Like most of you, except you have access to the internet on the lab machine, right? No one's done this before, just to be really clear. So I'm light on information because I have to still figure out a few details about this. However, one of the frustrating things is all of you students like to talk to each other, and some of you are aware of the hiccups we've had with the C++ exam last term. Now, the short story with this was that I wanted to do this for another course last term, and I was told I could, and then I was told at the last minute that I couldn't, and we had to go and change a bunch of stuff around, and it caused a bit of chaos. But this term, I've gotten really clear OKs early on from people, multiple people, saying that we can do this. So we're not going to have an issue this term. We're going to be able to do this. The other thing is that as part of these exams, I am going to figure out a way to provide you all with a way to practice on the exam environment before the actual exam too, if that makes sense. So that you can actually like play around and see what VS Code's like and all of that kind of stuff. I'm very student-oriented with this kind of thing. The exam's there to help solve a problem, but not at the expense of your well-being and mental health. So you'll just kind of have to trust me that I've done a lot of stuff in this school, and that will kind of get it right. And for anyone here who's sitting there being like, I do really bad at exams, maybe I'm really smart, but I'll just have a really bad exam day, and then Hayden's going to think I'm a cheater, and then I'm going to get 0, and then I'm going to have to listen to him in T1 talk about it again when I fail the course. That just doesn't really happen. When students, like if you have a student who's passed the course but failed the exam on a hurdle, you usually are able to like identify that student. You reach out to people like their tutors, their markers, like it's really, really obvious. You know, I know that sounds like a really high level comment, but you'll just kind of have to take my word on it. There's not really good people who get punished by hurdles. There's occasionally bad people who can skirt around it or maybe still find a way to cheat. But you know, if you're a student who learns your stuff and does okay throughout the course, you don't need to worry about this. And we will keep talking about it in the future. There's a question about what's the format of the final exam. We're basically going to give you a really small thing to make a front end of. So we're like, go make this thing, and we describe it to you, and you just go and code it up, and then a tutor marks it. And it's all manually marked. That's the other good thing, because everything in this course has to be manually marked. Because like front end's really hard to automate the marking of. So you know, if you kind of do something slightly wrong, but you mostly got there, you don't need to stress too much. Yep. Rules on ChatGPT. Oh, that's a good question. So rules on ChatGPT are, I usually say like use it like Google in terms of, like you all Google stuff all the time, but you know that if you had an assignment and you found something on Google and you took it and you pasted that in and it was like 50 lines of code, that's bad. You know, like you know that. It's just we can detect that like that really easily. So I just apply the same philosophy. It's like a tool to solve your problems. Like use it to solve your problems. So what I mean by that is like don't ask it to construct you big complex things. That's usually where it'll all go downhill for you. Use it to solve like targeted problems. I do that all the time. Paste some code in. I'll show you after the break and just be like, this isn't working. Why? Like I talk to it like I'm a desperate crying individual and there's a smart friend. And it's like a really good course correction. And if you can use it well, it will be helpful. But if you don't learn the stuff yourself, you're going to really struggle with it anyway. And also like a lot of ChatGPT code we can detect in this course, to be honest with you, because it generates so much a lot of the time. And I have spent some time on that, whereas for other courses it's a little bit harder. I'll answer a couple more questions, and I do want to get to a break so we can jump into the other stuff. There was one more, I swear. Oh yeah, will there be Super Mario music? Yeah. Why is object-oriented programming overused compared to, say, functional programming? You guys just assume I know stuff. I don't know. Like, I don't know a lot about functional. Every time, yeah. No comment. I don't want to conflate that I might know something on that topic. So let's take a break. 5-minute break, and then we'll get back to things. Hi, everyone. Welcome back. I'm just going to tackle a couple of points from the break. Firstly, I had a couple of questions about the hurdle. You know, people always ask, what's the hurdle? And, you know, you say, oh, it's 50% or something. Every exam I've ever run, I always make them a little harder than they need to be, and I scale people. So if you just, I can give you some generic answers, but you're not going to sleep at night with those answers. What I'll tell you is that, like, typically what we'd expect in an exam like this is if a student can score a mark of like 20 to 25% in the final exam, that's a pass for the exam, you know? So this is not some like massive mountain to overcome. So that's relatively straightforward. I also got a few other questions. Is ChatGPT allowed in the exams? Like, I don't know yet. Like, again, no one's ever done what I'm trying to do at this school as far as I've been told, so I don't know. Probably not. Again, I'm trying to figure that out in the next couple weeks. But probably not, because to some extent, there is a point where like part of us assessing you is trying to assess a little bit of knowledge, you know what I mean? Like, sure, we can be like, here's Google, you can get all the resources you want, but we're not going to give you access to something that can write it for you on the spot. So probably not. Assume not would be safer on that. But Stack Overflow, Google, all those kinds of things we're getting you pretty comfortable with. Tips to score above 95. I don't know. Do the work, I guess. I'm not sure. I don't really know what people expect me to say. Drink 2 liters of water as soon as you wake up, or something. Not that. Will we use Tailwind? Yes, you can use Tailwind. Can we use v.o? I don't know what that is. I'm sorry. I heard that one of the assignments is in pairs. Oh, yes, great question. I think I probably glossed over it. I was trying to go through this a bit quicker today because I know no one really wants to listen to me talk about the course. It's very meta. I glossed over assignments. Where the hell is it? Yeah, so assignment 4 is done in pairs. Look, doing assignments in pairs is an administrative nightmare. If I didn't make it a pair, my life would just be better. I do it because I think that it's fun for you. You can do it alone if you want to, and it's actually 30% easier if you do it alone, so you don't have to do it in a pair. But learn programming. Programming with other people is a great skill, so we'd like you to do it. But I also know that I don't want to ask you to put your hand up if you have no friends, but I know some of you don't have many friends, right? You're here, you do this course alone, you don't know anyone else in the course. You don't want to meet up with some random person and they just suck at it, because everyone knows group work's a bit of a pickle sometimes. So you can do it alone as well. That's totally fine. Cool. Okay, so moving on to the next part. So assignment 1 has been released. Actually, I'll talk about that second. I've changed my mind. So before we get to assignment 1, the very last piece of tonight was this slide here. It was a taste, making web browsers do things. I like to do this in the first lecture to really emphasize just how simple web stuff can be. I am just on my editor here. I use this old school editor because it's very lightweight. It's not a web app, which makes it very fast on my crappy computers, and now it's just a habit. But I'm going to go make a file here, and I will go and put it in, where is it, work, index.html, right? Now, I just made this file on a computer. It's just a text file. I can write hello in it. And what I can do is I can open up the file in the Explorer here, and I can dump it in the web browser. There's my page. My web browser is loading up my page. Now, that wasn't particularly hard. Here's the cool thing about web browsers and HTML, CSS. I can go and put a bold tag there. That's an HTML tag. It makes text bold. You don't need, it kind of makes sense, right? Everything inside that you want to be bold. B stands for bold. When I refresh my page, you'll notice that the text is suddenly bold. Now, here's the important thing. The web browser, if you right-click on the page and you find View Page Source, and I open this up, it'll open this up in a new tab. This is the source code that the web browser compiler gets. And what it compiles, instead of machine code, is a pretty page. That's the pretty page. It renders the page instead of producing machine code. So if I go and write some more stuff, I'm going to make, say, Hayden italics here. Can't spell my own name. If I refresh the page again, it looks like that. HTML has a lot of stuff in it. There's a lecture on this, the HTML Fundamentals lecture, so I don't want to waste too much time on it. But you can do a lot of different things. I can go and create an unordered list of items where I have item 1, item 2, item 3, like this. And you'll see a lot of HTML has open and closed tags, right? It's pretty straightforward. We know this from braces with programming, open brace, closed brace. And there's lots of stuff. I can go and grab an image. So for instance, the course website here has an image. I can go and grab the URL of that image if I want to. That's the URL of the image, and I can say, go and include that. I can say, here's an image source that I'd like to include on my page. Tags, every HTML looks like this, has a tag name, and then some HTML tags, a lot of them actually allow you to add kind of attribute key pairs. Cool. I can add more stuff here as well if I'd really like to. But there's the picture. I can add things like a width if I want to, width of 100. I don't know if I can do this, height of 300. There we go. Beautiful. If I make it really skinny, it might just look like a bit of artwork. So lots of stuff. That's all HTML. I haven't used anything fancy there. HTML is kind of the foundation, and CSS and JavaScript layer on top of that. if I would like to introduce CSS and JavaScript into my site, then the simplest way that I can do that is to add it in like this. I go and write style. Style is an HTML tag that says everything between these style tags is CSS. And what I put inside those style tags, in this case, I will say that I would like the image to, what's a good example? I really love the attribute border radius. So what I'm going to say here is that all the images, here I'm saying apply these properties to the image tag. I would like to have a border radius of 20 pixels. What that will do is that'll take my image and it'll create a 20 pixel circle kind of mask on, there we go, a 20 pixel circle like mask on those things, right? So you can kind of draw circles around the corners. Those circles have radiuses of 20 pixels and it gives that effect there. I can also say I'd like to add a box shadow. And when I add box shadows, I think I don't remember the exact description, but I think it's something like I want my shadow to be 5 pixels to the right, 5 pixels down. I want the shadow kind of how blurry it is to be about 10 pixels, and I want the color to be gray. And now I have a shadow on my box, right? And there's lots of different ways you can write that kind of stuff. But that's me now adding CSS. And now suddenly it's very beautiful, isn't it? If I want to add a little nearly black border, I can go and do that. So now it's got like a nice little sort of stuff there. And I don't really know what else I could do right now. Kind of looks cute, right? So that's CSS. We've made a thing prettier. And it's just that on steroids. There's lots of different ways to describe what it applies to. You can apply it to multiple things. You can apply it to things based on certain tags. You can say, I want you to apply this to all of these things, children. And you have many different properties as well. The amount of CSS properties that exist, like list of all CSS properties, there's a lot. There's like quite a lot. And most of them I don't even know what they do, because I probably only use the same 30 most of the time. Like rotate. Here you go. Rotate 30 degrees. I rarely need to rotate stuff, but there you go. We rotated that. Looks so trendy. That's CSS in a nutshell. That's cool. Questions about CSS? Okay. Thrilled, aren't you? The other part of the website is, and maybe let me just give that, let me make that further down the page so I just have a bit more space. There we go. So now the next part's JavaScript. JavaScript is similarly, I can include it on the page, except instead of writing style, I write script. Because everything inside those style tags is CSS, right? This is all compiled by a CSS engine. And everything inside here is compiled by JavaScript. Now, if I want to print something in JavaScript, I write console.log hello. Now, where is this going to print out? It's not going to print out on the web page. It's going to print out on the console. The console is something you also learn about in week 1. If you right-click on your website and you click inspect, this box comes up. And you can find the console in it. And you'll see the words hello there. So printing in JavaScript doesn't kind of display something on the web page. It prints to the equivalent of a terminal for the web browser. That's where that hello is. But I can do some funny things with JavaScript if I want to. For instance, I want to make a button. This can be our activity. That every time I click it, right, I want my background to rotate, right? I'll get that up on the screen. Thought someone was funny. I want it to rotate. So what I'm going to do is I'm going to go make myself a button. What should I have the text in the button say? What's your favorite fruit, my friend up the front? Everyone will remember this forever.
Apple.
Apple. Went safe. Okay. Is it really apple?
Yeah, the red apple.
The red? Oh, that's good. I don't like green apples. They're too sour for me. Yeah. Yeah. People think I'm crazy. So I have a nice. Oh, by the way, remember emojis are text, so you can put emojis anywhere. Cool. So Apple. I got a button. Now, when I click the button, nothing happens. That's just the HTML standard, the browser implementing that, not doing anything too interesting there. But what I'd like to do is I'd like to give my button a particular ID called, I'm going to call it do rotate. I'm just making that name up myself. That doesn't mean anything in particular. And what I'm going to start doing with my JavaScript down here is I'm going to say, hey, document the whole web page. I'd like you to get me a particular element on the web page called do rotate, right? Now, if I console log, which is the equivalent of print in JavaScript, if I console log that out, remember, I'm not teaching you anything here tonight. I'm just kind of getting you excited. It'll print out that button. So it's like, OK, this piece of JavaScript is capturing that particular button. Now, what I would like to do from there is I would actually like to say, hey, on that button, I would like you to add an event listener. Now, adding an event listener is simply where I tell it, you are going to listen for a click. I'll just make this bigger for a sec. And when a click happens, you are going to call a particular function and do something, right? Now, this is just an anonymous function, but I could go and define it and say, like, do rotate and say, like, function do rotate here, like that. And I could say console log go, go, go. And now what's going to happen, if you think about it, is that, you know, on the page load, it gets the whole web page. It looks for a particular element. It adds a listener to it and says, hey, on that element, listen for a click. And when someone clicks you, you're going to call do rotate. So I'm kind of defining behavior. Remember how I said JavaScript is basically listening for clicks, keyboard presses, or a time to happen, and then a result to occur. So now I click that, and when I click go, 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 because it's the same text, the number's increasing. It's still printing it out every time. But I don't want it to do that. I would like it to make my image rotate slightly. So what I'm going to do now is give my image an ID. In this particular case, I'd call it city. And I'm going to figure out a way to update its rotate amount. Now, first thing I'm going to do is try and print out what its current rotate amount is. So I'm going to do the same thing I did before and say document.getElementById. I'd like to get the city. And then if I'd like to access a particular CSS property, I can actually say style.rotate. So style is me trying to access a CSS property of it, and then .rotate is a particular one, and then I would just console log it. Now again, I keep reiterating this. There is a whole 3 hours of pre-recordings to start teaching you some of this stuff, and we don't even do the JavaScript till like week 3. So from the JavaScript part, that's like not a problem for a couple weeks. And then I'm going to hit refresh again. And I'm going to click that button, and I can see that it printed out nothing, which is weird. Style.rotate. Oh, it's probably because I didn't set it with. Let me just set it as like. Yeah, it's all right. We'll play with this. So rather than make it actually change much, what I'm going to do here instead is I'm going to say, you know what? When someone clicks that, I would just like to set its rotation to 40 degrees instead of 30, right? Because it's 30 currently, and I want it to be 40. So I save that, and then I hit it. It rotates a little bit. Cool. But every time I click it now, it's going to not change anything because naturally it's already at 40. But another thing I could do, if I'm going to be really cheap about this just to get the example done. Let's let it start at 0, and let's say that every single time I click it, I would like it to be, angle degrees. That's what I'm going to set it to. And every time I click it, I'm going to increase angle by 10. And if angle is greater than 360, angle minus equals 360, right? To like deal with the full rotation stuff. I don't know if that works. But that's what I'm going to do. So we start off with an angle of 0. I'm going to get rid of this. And then what happens is I click that button, and it just starts rotating, right? So I click that as much as I want. And it's just going around. And you know what? Now, I don't really want it to do that based on a timer. I would actually like to do that based on a recurring thing. So I actually want to say, you know what? Every 1,000 milliseconds, I want you to call do rotate. That's 1 second. Tick, tick. It's really boring. Let's speed it up. Let's speed it up again. It's kind of nauseating. I'm going to zoom out a bit so I don't have to look so deeply at it. It's kind of pretty. My favorite thing about teaching this course is that I just so you know, I don't plan this at all. We just kind of do stuff together. I wasn't at home being like, yes, I can see it now. It's going to be a spinning rainbow. But you can do stuff, right? That's JavaScript. JavaScript's adding that doing stuff element to things, and CSS was kind of giving it I can't stop it. Giving it the colors. You could make it try and be even smoother if you wanted to. Let's increase it by just 1 degree. Whoa. And then we'll speed it up even more. Now, obviously, there are limitations to this. I won't go into it too much, but we had some interesting questions tonight about performance and things, right? The web browser trying to make this spin is way more computationally heavy than if you were to write, some really low-level, C++ thing that just rendered something and made it spin. That's why games aren't made in this, right? Like the amount of CPU time that would be spent, because you have to go through all the layers, right? JavaScript's got to talk to CSS, it's got to talk to the web browser, it's got to talk to the operating system. Got a lot going on at the same time. So, there are limitations of it, which is also why, probably not at the moment, but I usually point out apple.com is a good example of a website where they really push the limits of what a web browser is going to do, like this stuff here. I don't know how that's done. If it's a video, well, there you go. See? Do you see it like lag a bit? It's like a $4,000 laptop I have here, right? It's like works, but it's like, it lagged the first time. It might have been a network thing. I don't know how they're doing this. I could probably check. It's probably a video. It looks way too clean to be something a web browser could do. But again, I don't really want to waste a lot of your time me hunting it down. But it does look a little bit, oops. Why is this so? Ooh. Sad. Apple.com. No, they just don't like me there. Okay. I don't know. That should work. Apple.com/ that. I don't know. They're very smart. So I'd be interested because you could do this a bunch of ways. It could be a series of images that they're just like cascading really rapidly. It's probably not going to be in CSS. This is way too complicated for what CSS could do, as far as I know. And if you tried to do this in CSS, you would actually probably kill the computer because it would be so much to render, like so many calculations to do. I think I told people that, I usually tell people on my website, this background here actually used to be like a lava lamp. It was the designer made like a lava lamp background. It was beautiful. It would kind of just like, lava lamps. You like just watch them change color. But when we implemented it, we had a bunch of customers tell us that the websites crashed on their phone because like there was so much CSS going on, so much to compute that it actually just like completely collapsed. So I see something like that and I think it's a video. It doesn't really matter. This is just me going on a tangent. But the point is that I hope that you start to think about some of this stuff more by the end of the course. And I hope that this gives you a taste of what kind of the next 3 or 4 weeks is like. But all that JavaScript aside, let me unwind it. Actually, I'll keep it. Let me save it in a file so that there's always one student who's like, can I have the code for the rotating rainbow image? And I'm like, OK, let me find it. Oh, yeah, on that note, code should be uploaded like here. You could come to today and click on this like access the code, but it's not there right now. So if I come back to this, it's just HTML and CSS. And that is what your first assignment's about. Your first assignment is here on the course website. Now, with the course website, that image is really big. I should probably go and change that. This is the assignment. Now, the actual details of the assignment are in this link here. Please see through here. When you click on that, you'll get taken to the task itself. The reason for this is new this term, is that basically everything you see on this page here is used every term as the same stuff, whereas like the actual task you're doing, which changes every term, is on the link and on GitLab, right? So you'll see kind of all the meta of the assignment. Like here's the gist of the assignment. Here's the lectures you need to watch. Here's how you can do lots of stuff to help. Here's the marking criteria. Here's the rules. But if you actually pay attention to it, the assignment itself is basically giving you 3 questions, task 1, 2, and 3. And we're asking you to write HTML and CSS so that you can produce a page that looks like those images. So for instance, task 1 here, we want you to make a page that looks like that. That's it. So, there's an image, there's like a gray thing on the side with some icons and some numbers and some text of different sizes and a love heart and more text and text and text. So that one's like the easier one. In some ways, it'll be the harder one because it'll be your first one. You know what I mean? Like you can kind of settle into the assignment a bit. The second one we want you to do, it looks like this. It's a bit more form stuff. This one you'll probably find the easiest because you'll have been warmed up by then. The first one will challenge you a bit because it's new. But this one's pretty easy as well. And then your third task, we actually get you to make a page and we get you to make like the big version and the small version. So this one's like how it would look on desktop, and this one's how it looks on mobile. And we want you to make a web page that when someone resizes your web browser, it actually like changes. And this is all in the lectures, so you learn about this stuff. But that's what the assignment's about in a nutshell. We do different questions every term for this, so it's a brand new assignment. I will tell you up front that I actually think this is probably the easiest one I've ever seen. That's good for you. I just don't think the questions are super hard. Sometimes there are terms where they're a bit harder, you know, because it's hard to make them match exactly. But yeah, that's the assignment, is you just write HTML and CSS. So you literally go and like go to GitLab, you go to clone that, you just go git clone and you paste that in after you've set up your SSH key if you haven't already. You go into the assignment called pick to code, and then you just have a bunch of stuff here, you know, task 1, and you can go and open up. You don't do this in the freaking terminal, but you can go and make your HTML page there. That's it. You just write HTML and CSS. There's a lot to unpack because you haven't watched the lectures, but that's the assignment. That's all you're working on until the end of week 3. Okay? Now, the good thing is that I've asked your tutors to mark this by the end of week 4. So all of you are going to get your marks for assignment 1 before census date as well, which I understand generally students appreciate. So that should be good too. But week 3 will creep up on you a tiny bit, but it's not that bad an assignment. It'll just feel fiddly. There's lots of questions here about, you know, how should things look and stuff. It's mostly answered in this web page. Yeah, probably some key points. I don't take late submissions in my courses. I explain this all the time because otherwise someone asks. If I have a late submission period or a penalty, that means that the assignment wasn't really due then, you know? So like, let's say I'm like, oh, it's due on a Friday night, but I accept late penalties till Sunday. Well, we're not going to start marking it till Sunday, are we? Because we need to let everyone submit. Well, I'll just let you have it be due on a Sunday. So we literally have it due your tutors literally start marking this like half an hour after the final submission. So it's already due as late as it possibly can. I usually make the joke, if you want a late penalty period, I'm happy to bring the assignment due date forward for you and then put a late penalty period in. But there's no late penalties because there's no late submissions. Everything's submitted on GitLab. A couple of notes here, though, that are important. The marking criteria. Half of the marks come from if it looks right. Half of the marks come from your code quality, which is mostly the style guide and things like that. So pretty light assignment. Code quality is pretty easy to get right. You just kind of have to follow some rules. The style guide has everything there, but there's some sets there. Generally speaking, there's always the question every term, how close does it have to look to the image? What we usually say is that it has to look pretty good within a couple of pixels, right? Your tutors don't look at what you draw and compare it to the image with a ruler, you know? But they look at this every day, and I can tell you right now, it's pretty obvious if someone makes something that looks more than a few pixels off. And the good thing is, like, if you're more than a few pixels off, you haven't really gone to check. And there's a few things we have in here, like tools and stuff, where you can just literally open these up in tools. There's a bunch online. This one's from like 4 years ago, so there's going to be a whole bunch more, where you can just highlight an area and it tells you how big it is. You know what I mean? Now, I also get the question a lot, which is like, why are you giving us JPEGs, Hayden? Why don't we use a tool like Figma, which is like an industry standard tool where you can go and like draw stuff up. And the cool thing about Figma, I'm going to get a whole bunch of freaking influencers being like, oh man, this person's really got some purple background. That is a lot of LEDs. So there are these tools like Figma where people go and design it, and then Figma will like take that and actually like spit out the CSS and things that you can use, you know? So it'll give developers a lot of code that they can actually go and copy and paste. They're very useful tools. The reason we don't use them is because we're simply trying to help teach you the fundamentals. That's really it, you know? Like a lot of like we're here at uni to learn stuff. If we were trying to skip a bunch of the learning, you don't really need to be here. But the reason too is because the idea that in industry people just make designs and you as a programmer just kind of like copy and paste them into the web page is like often rarely true. Rarely true. There is always a gap between designers and engineers. I've never seen this not be the case. I'm sure there are exceptions. But designers don't think like you a lot of the time. That doesn't mean you're smarter than them, and it doesn't mean they're smarter than you. What it means is that the way you think about web pages is often a lot more detailed. A really good example is a lot of designers, when they go make pages, they make these beautiful pages that look kind of portraity. But most people have screens that are quite landscapey. They won't be thinking about all the different screen sizes all the time. You know, like as engineers, you'll often be like, oh, what about this really obscure edge case? So actually, you know, getting into the habit of taking ownership of how things look and programming it all yourself is a really important first step. And we don't ever ask you after assignment 1 to make anything that look that specific again. You know, so it's like a one-off exercise in your control over CSS. And you might be thinking, God, CSS is fiddly. It like feels like I'm just managing pixels. You know, like, oh, it's just got to get to this right point. Truth be told, I wish it wasn't the case, but that's actually what the experience of most front-end developers is like every day. It's just fighting the details constantly, you know? So it's not that dissimilar to what it's like in reality. There's really not much else here, probably just this last one. This is something I'm introducing into some more of my courses. The purpose of it is I want to create more guide rails for how work is done. This one's really important, because I want to get better at encouraging students to use tools like ChatGPT in their assignments. If you've done a course with me last term, you probably have heard about this, so I'm sorry for repeating myself. Basically, what we ask you to do is we ask you that during this assignment, we expect you to make a commit on Git, right? That basically means like you have to like save your work on Git. Like with Git, you commit your work. It's basically like hitting save. If you're not sure what I mean, it's like, you know, if you had Dropbox or something, it's like hitting upload, whatever. You can think of it many different ways. We want you to do at least work. We want you to do work on at least 4 unique days between now and when it's due. So today's Tuesday, right? Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. It's a lot of days. It's like 19 days or something. I don't know how many it is. You need to do work on at least 4 of those days. That's one requirement. The other requirements that you need to make at least 30 commits across the course of the assignment. They can be one-line commits. It doesn't really matter. You could like modify one line or do a couple things and just make a small commit. You also need to give your commits meaningful descriptions, which means like when you make a change, you actually say like, you know, I'm doing this small change. And then the last one, which is really important, and this one's super, super important, your commits cannot be more than 100 lines in length, right? That means that once you have to write less than 100 lines of code before you make a commit. I'll quickly kind of demo that as the last thing here, but I just want to explain this. This is not me being an asshole. It would be really easy to do that. The reason for this is because what this does is this forces you as students to work progressively through something, and then really importantly, show how you work through something, right? You think back to high school when we talk about mathematics, how they say, you know, don't just write your answer down, show you're working, right? Does anyone else have that kind of PTSD sound in your head of like, show you're working, show you're working, show you're working? It's a lot like that, except these are pretty light requirements. We're not saying you need to work on it all the time or you need to commit 10 lines of code at a time and explain everything. It's just a little bit, because if we get this right, and to some extent, you know, you guys are a little bit of a test bed. Every term is being tested in some new way. It means that we can start saying to students like yourselves, and in a lot of ways I'm saying it now, use ChatGPT if you want to help solve this problem. You know, describe something, help it let you write code, because we're saying that if you can use some of these tools but still demonstrate to us that you know how to progressively work through a problem, then you have shown that you understand stuff. So, short story, we're simply saying here, the understanding is not demonstrated simply by the result. It's also partially demonstrated by you showing us how you got there. That's really it. Different assignments are done differently here. For instance, the last assignment, because React.js is so complicated, we actually have a lot higher limit there. But just to be really clear to people, I went and cloned this repo here. You saw before. What I do, and it says right at the start of the thing here, please run .util/setup. That's what you just have to run once. That'll then make sure you don't overcommit stuff. And then all we're saying is like, as you do work, let me just get it up. What is it? What thing is it? Pick to code. Pick to code. Here's your assignment, right? So you're over there, you're doing the first assignment, and then you do some stuff. You make a little HTML page. You say head and title, and then head, and then body. And let's imagine you go and do a whole bunch of other stuff, right? Maybe you work on it for like 20 minutes or 30 minutes, you know? You're way less than 100 lines of code still, right? And then what happens is you say, oh, I've done a little bit of work. So you you come here and you simply say, Git status. And if you're a postgrad and you haven't done with Git, remember, we've got these lectures to help you. So you'll just have to kind of like gloss over what I'm doing here and come back to it after you look at the Git lecture. And I'll say, oh, yeah, I'm going to Git add that. For all the undergrads who have been like beaten into like Git, like you need to use Git a really specific way, we don't give a crap in this course how you use Git. Just get it committed and pushed. It doesn't really matter, right? So I'm just going to Git add everything, which I'll always do, and then I'll just add a message saying added structure for task 1. That's it. You don't have to push it. You can. Pushing it's a great idea because you back up your work, but you don't have to push it, right? Like you can just commit the entire assignment and not push it up. But that's what we're saying. So we're just saying you literally just have to do a commit. I just made one of them then. You just have to do 30 of those across the thing. Probably change that to 20. I feel like 30 is a bit high. It's not really high, but you're going to feel like it's high, and I care about how you feel. So I'll probably just update that to 20 here. So consider it 20. So 4 days, 20 commits. They're not hard to do. There's a bunch of students who'll make 20 commits in one day. They need to have meaningful descriptions like I wrote, and they need to be less than 100 lines of code. The util thing we run, that will simply stop you making a commit if you write a lot of code. So for instance, if I do this here, and I say like dumb name, it should stop me. And it says, looks like you're trying to commit 140 lines of code. And you'll essentially just have to not do that and maybe like, take some out, commit less, like just, again, show us that you can progressively build a web app, Any questions about that? Yep.
What time is like the deadline? Because it's just
Oh, does it? Oh, I'm sorry.
the course
8 p.m.
Oh, 8 p.m.
Yeah. So most assignments are due at 8, so you can put it behind you and have a nice evening, really. I hate it. There used to be assignments due at 8 a.m. I used to hate it. Like, who would do that? Cool. Any other questions about that? Assignment 1, the spec, and things like that. I know most of you haven't looked at anything, just to be clear. I'm not trying to like pound thoughts onto you. Like you're gonna go away from this. You're going to watch the pre-records this week. The postgrads are going to watch the Git lecture, and then you might see some of the stuff I did tonight or think about it and be like, oh, that makes sense. But I'll just go through some of the last questions I have up on the thing before we wrap up today. Don't get too excited. I know you all start to, once one person starts packing their bags, you all go a bit crazy. So even if you block ChatGPT and other websites like Gemini, how will you block someone who get their own fine-tuned model of an LLM and host it? Right? There's a great question. We're going to have ways to keep an eye on you during the exam so you don't do something dodgy. Can you put assignment code publicly on your own GitHub? No, you can't put your university submissions on a public GitHub anywhere. That's university policy. It's not course policy. What time is the first assignment due? We got that answered. How to weigh the weight of assignment and exam. Will the assignment be reduced because of the existence of the hurdle? No, the hurdle's just like a minimum requirement in the exam. It has no determination of your final mark in general. And then is the next live lecture next week? Yes, we only have one lecture every week because there are pre-records. We could do 2 lectures a week, but then you've got to do 4 hours of lectures plus the pre-record. So we just do one so that you only have so many things to watch. If you do have any questions about stuff, please post it on the forum. Go watch the pre-records. I'll email you on Friday, and I'll see you next week. Cool. Aww. That's very sweet. Thank you.